be a short video as promised where I'm going to implement the acceptance rejection method for this beta distribution in Python, because there's some issues, not the least of which is that Python doesn't have a do-while. But we'll cross that when we come. Just as a review, where the beta distribution with an alpha of 3, a beta of 1, the PDF for that is simply 3x squared. And we're going to use the triangle majorizing function, and the formula for that is 3x. Now notice that our majorizing function is not a PDF, and the only thing that's keeping it from being a PDF is the fact that its area is greater than 1. In fact, here the area turns out to be 3/2, which we could have done by calculus, as I've done here, or simply noticing that 1/2 the base, which is 1, times the height, which is 3, which is 3/2. So whichever way you want to get there. But if we take our majorizing function and divide it by the area, then we have its area is 1. Then it is a PDF. But the key criterion is this ratio of the PDF that we want divided by the majorizing function, not the normalized majorizing function, the majorizing function itself. So that would be 3x squared over 3x, which is simply x. And so our method is to, we generate a u and a v, and then here we're setting y to be the root v. That will generate our trial, which is going to have a triangle distribution, but for the do while, we do that while u is bigger than y. So that's the algorithm, but for and the reason it's a do while is because we want to make sure we do it at least once. So now for the Python, let's I'll put it in this random one and just create a class Beta3 We're hardwiring in what the parameters are. It's going to extend random variate. We still need the constructor and the superclass constructor. But all we need to do is define the generate method. Okay, so now the problem is that we don't have a do while loop. We have a while loop, but not a do while loop. So here's one way to do that. We can create an infinite loop and then break out of it at the out. So what are we doing? We need a u and we need a v. And then we're going to set y to be simply the square root of v. And then we do that, and now we can simply say that if u is less than or equal to y, so we're kind of flipping it around, then we're going to break, and then we're going to return y. Okay, so let's test that out. And from there, random import this, and then import sys, and then that's width, and let's let's see and we want to write that. We want 100,000 of these. What do we want to do? Oops, we need our, that's instantiated. We don't have any parameters, so okay, so the Beta3 1 generate, and then and hopefully this works. Let's see. All right. Let's just sort of check. Okay, there it is, and we got numbers there. And so now we can kind of come back to our R. Yeah, I just want to read K. It's just a little too aggressive with its suggestions. So we want to input this. So this was what I call a Beta3 1 Python. And yeah, that should work. All right. And now we want a histogram of data. Okay, so that looks pretty good. Let's do it with 50 breaks as well. Okay, we get a little finer one. And as you can see, it has the right shape. Now it is curved, and we have our, it goes up to roughly 3.0 since we didn't do the other. And that is how you do it in Python. And just this is just sort of another way of doing the do while loop, making sure that we execute at least once.